Hi class, this is Mrs. Cribb. We're going to go through a review video now, do some review questions to help prepare you for this test that's coming up for Chapter 9. So here I put up a question. I'm going to try to review all the major math that you need to do here. The question is, what mass of zinc oxide is formed when 20 grams of MoO3, molybdenum oxide I guess, is reacted with 10 grams of zinc? Okay? So here's the balanced equation. Now remember, you always have to start with a balanced equation, and if it's not balanced, you're going to have to balance it first. Okay? I didn't want to take the time to balance this equation just because we've done this a lot, and I'm hoping that you're pretty good at that. So now we're going to start with 20 grams of this molecule. So I'm going to write it right underneath here. 20 grams. And 10 grams of zinc. And hopefully you can see that this is a limiting reactant question because it's asking me how much zinc oxide can be formed. So we're going to need to do two mass-to-mass questions. And I'm going to go ahead and write the pathway. I really want you to remember the pathway. The mass of A goes to the moles of A, and you use the ratio bridge to get to the moles of B, and then to the mass of B. And when you use the ratio, it's always the B over the A, and the ratio comes from the coefficients in front. Now, sometimes you're going to start with moles and goes from mole to mole, but you have to start wherever you need to start. In this case, we're going to have two A's. We have this molecule that we know something about. That's going to be our first A, our A1. And then we have this molecule we know something about, and that's going to be our second A, A2. When we do a limiting reactant question, it's asking us which one of these two molecules stops the reaction from going forward, because one of them is going to be all the way used up. And so the limiting reactant is always going to be on the reactant side. This is the reactant side, okay? The reactant side. The other side is the product side. So we're never going to be talking about a limiting product. We're going to be talking about a limiting reactant. Now the question is how much zinc. So we're going to end up with two answers. We're going to have two things to look at. We're going to have an A1 answer and an A2 answer. And basically, both of them are going to give you be in grams. That means I'm going to start with A1 and determine how many grams. And then I'm going to start with A2 and determine how many grams. Now these A's and B's are just kind of to help you to think through going from something you know to something you don't know. Alright, so we start off with the first one, A1. We have 10 grams of zinc. Now notice I'm not using this 3 yet. I'm using this down here, these quantities. This balanced equation right here, the balanced equation is kind of like the recipe. And so everything has to follow this recipe. And you use these coefficients to figure out the ratios between the ingredients. Well, I don't have 3 moles, I'm using 10 grams. So I'm going to start off with these 10 grams, and I have to figure out how many moles that is. So this is where I am right now. I'm at A1. I have the mass of A1. I'm going to need to go to the moles using the molar mass of A1 to get to the number of moles. So 1 mole is on top, and I need to know the molar mass of zinc. And so I just need to look that up on the periodic. Okay? And so now if I look it up on the periodic chart, zinc is 65.38 grams. So that's the molar mass. This is the molar mass of A1, the zinc. And so if I cancel out my units at the moment, I could cancel out grams and grams. Make sure your units cancel. And then I need to move on. I have just gotten to the moles right here. This is where I am now. I now have the moles of A1, because this would be moles of zinc. And zinc is my A1. So I'm going to go from moles of A1 to moles of B using B over A. And so my B in this case is zinc oxide. So this is where I use these coefficients. So 3 moles of zinc oxide and 3 moles of zinc. And you need to go ahead and write down the molecules, otherwise you're not doing the work right. You want to make sure that everything's going to cancel. So I'm going to go ahead and cancel my units now. Now that I have zinc in the numerator and zinc in the denominator, and it doesn't matter that zinc's way over here, just like if you have 2/3 times 1/5 times 1/2. Notice that this is a 2 and this is a 2. Those can cancel even though they're not right next to each other. And that's okay, because in math you can rearrange things that are multiplied together. And so still it's a numerator and a denominator. Okay, so now I can also cancel out this moles and this moles. And right now I have moles of zinc oxide, which is zinc oxide, and it's the product, it's the B, because this is my B over here, this is my B. So I've just gotten to this spot right now. I'm at moles of B. Okay, now I need to turn moles into mass. So I need the molar mass of zinc oxide. I'm going to calculate that over here. Zinc and oxide. Now notice this. I'm taking the molar mass of zinc oxide, this molecule right here. I'm not using the 3. There are not 3 atoms of zinc and 3 atoms of oxygen. For the molar mass, I just want the mass of one molecule. So there's only 1 atom of zinc and 1 atom of oxygen. And oxygen is 16.00, and zinc I just found out was 65.38 by looking it up. And so I need to very carefully add those two numbers to get the molar mass. Pull up my calculator. Okay, I have 65.38 plus 16, 81.38. 81.38 grams over 1 mole. It's only 1 mole. There's the molar mass of B in this case. All right, notice the units, grams over 1 mole. You have to have the units. All right, so I have moles on the top here, so I need 1 mole on the bottom and 81.38 grams on the top so that my units can cancel again. Moles and moles cancel, and then this is going to give me my first answer. So I'll pull my calculator back up and we'll do this math. So get it over. We have 10.0, and I'm just putting that in so you can see all the significant figures matter, divided by 65.38. And now you can see the 3's are there. You can multiply by 3 and divide by 3, or in this case they would have canceled out, but that's okay. Times 81.38, and that's 12.447. I'm going to write that raw answer down. 12.447. Now we have to check sig figs. Notice that this number has only 3 significant figures. That's the measured value, so I need 3 sig figs, 1, 2, and 3. So that's 12.4. That's my first answer, 12.4 grams. All right, now I'm going to do the same thing with A2. So A2 was this one right here. So we're starting with 20 grams of MoO3, and then MO is molybdenum. Okay, so I got to turn the grams into moles, and I'm going to calculate the molar mass over here. So MO and O, and 3 of them. There's 1 MO, 1 molybdenum, and 3 oxygens. Again, I'm not using the coefficient to figure out the molar mass. It's the mass of one of these guys, one of these molecules. So molybdenum's molar mass, if I look it up on my periodic chart, and I'm just using the periodic chart that's in your textbook for these calculations, is 95.96, and then oxygen is 16 again. 3 times 16 is 48, so 95.96. I add those together to get the molar mass here. So we have 95.96 plus 48, so 143.96. 143.96 grams over 1 mole. So that's the molar mass of this new molecule. So 143.96 grams. So now I can cancel it out, grams and grams. And the next step is to do the ratio. Remember, the ratio is the B molecule over the A molecule. So I did the same thing here. I need the B molecule is the same as it was before, 3 moles of zinc oxide. And then this time we have to use this molecule. That's my new A. So it's 2 moles of MoO3. And now I'm going to turn mass to moles. So now I'm going to go ahead and cancel first. There's the molecule that I can cancel. And here's the mole unit I can cancel. So I have moles of zinc oxide. And I'm going to turn it into mass. And I've already calculated the molar mass, because this is where we use the molar mass of molecule B. I used it up here and down there. And so now I just got to put it in and calculate my new number. So 20 divided by 143.96 times 3 divided by 2. Notice I don't even worry about simplifying it. Just put it in. Times 3 divided by 2 times 81.38. I get 16.95. But if you look at significant figures, there's 3 significant figures. So I got to turn this to 3 sig figs. 1, 2, 3. So that means, look at the next number. That's a 5. That causes the 9 to round up, which is causing the 6 to round up. So it's 17.0 grams. So that's my A2 answer, 17.0. I already got the unit down there, grams. Okay, now, there's your 2 answers. Now we have to compare them. And we want to find the one that's smaller. This one is smaller. The smaller answer is what's going to actually be created. So this one is the one that's created, the grams of zinc oxide. And that means that all of this is used. If all that's used, that means this is the limiting reactant. This limits it. When all 10 grams of zinc is used up, I made 12 grams of zinc oxide. I cannot make any more in this reaction. When I use all of this up, all the zinc up, I can only make 12 grams. I can't keep going because I've run out of zinc. So this is the limiting reactant. And what we say about this other one is this one we have extra or excess. This is the one I have excess. We have too much of that one. So what is the limiting reactant? Zinc. So that's the answer to that question. What is the excess reactant? That's the one I have too much of. MoO3. Okay? Now we're going to determine how much extra reactant of the excess is left. So I've given you kind of a clue over here. The amount given, so the amount given of our extra is 20 grams. It's right here. That's the amount given, 20 grams. Excuse me, 20.0 grams. So I need to figure out how much is used in grams, and then I'm going to subtract the 2, and I'll know how many grams are left over. Okay? So I need to figure out how much is used. Well, how do I do that? I go back to the beginning, and I know that all 10 grams is used. All is used. All the 10 grams of zinc is used. But I don't know how many of the 20 grams is used from this molecule. So I have to figure out how much of this molecule is actually used. I have too much. 20 is too much. Some of it's going to be left over. How much is left over, I don't know until I know what was actually used. So this one really becomes your new B. This becomes your new B. This is your second B. So now I'm going to go from here, from that amount, the 10, to the new B. Zinc is your new, zinc is the A again, but the MoO3 is your new B. So we start with 10 grams of zinc again. It's another mass-to-mass equation. 10.0 grams of zinc, because all of that is used. I turn it into moles. 1 mole is 65.38 grams. I know that already because this is the molar mass of A. And then I need the B over A ratio. Remember that the ratio, B is always just the second molecule. All right, I'm going to rewrite the equation just down here so I don't have to flip back and forth. We have 3Zn plus 2MoO3 yields MO2O3 plus 3ZNO. Okay, so basically I'm starting at the 10 grams here and I'm figuring out how much is used. So I go from here to here. This is your new A and this is your new B. And go from mass to mass to know how much of this is used. It doesn't matter that I have 20 grams. That's the amount I'm given, but it's not how much I use. So I do the ratio. 2 moles of MOO3, and I get that from the coefficient again, to 3 moles of zinc. And I also get that from the coefficient. Okay, so cancel grams and grams, zinc and zinc, moles and moles, and then I'm going to, since I'm asked, I need to know the mass, I'm going to have to change it into mass. So 1 mole, I need the molar mass of the new B. In this case, the B is MOO3. And I already calculated that molar mass right up here at the top. So I get to use the same molar mass, 143.96. Now be careful that you got, this is MOO3s. You got to make sure you get the right molar mass written in. Cancel your units, mole and mole, and now I should be able to know how much I use. Okay, how much was used? Let's pull it up, turn it back on. All right, we have 10 grams divided by 65.38 times 2 divided by 3 times 143.96. And I get 14.67. I'm giving you more sig figs than you need. So 14.67. And then I have to look at my sig figs. I have 3 sig figs at the beginning, so I need 3. 1, 2, 3. So this is really 14.7 grams of MOO3 are used. So since that's the given amount, now I'm going to subtract 14.7 from the amount that I was given, the amount that was put in the vessel, and I'll be able to know how much is left over. So 20 grams minus 14.7 grams is 5.3 grams. 5.3, whoops, it goes down here. 5.3 grams is left over of MOO3. That's your excess. That's the stuff that you did not react. So what's that mean? That means in this, excuse me, in this reaction at the top here, even though I was given 20 grams right there, I only use, how much was it? 14.7 of those. I only used 14.7 grams. So that's 20 is too much. I only used 14.7 grams. All right, let's move on. So now it's asking me how many moles of this molecule are produced. How many moles of MOO3? Well, we didn't produce MOO3. We're going to, how many moles of it are really, how many moles are used? Let's change that produced to used. Okay? Because MOO3 wasn't one of my products. MO2O3 was. So I could do that. I'm just going to change this. All right. So I know here's how much I used. 14.7 grams. If I turn that to moles, I would say 1 mole is 143.96 grams. And then I'll have how many moles? So 14.7 divided by 143.96. 0.102. 102 moles. Now, this is using this number. I did this calculation using this number right at the top that we already used, but if you want to really make sure you don't round too often, you should start with the limiting reactant. Most of the time you're going to start with the limiting reactant and go to what we needed. So again, we turn the mass into moles and then just do the ratio. 2 moles of MoO3 to every 3 moles of zinc. And that, since that's as far as I need to go, because I'm canceling out grams and zinc, and grams and zinc, and moles, and I just got MoO3. I'm going to pull it up and see how close it is to the number I just did. So 10 divided by 65.38 times 2 divided by 3.102. Same, I got the same thing. 0.102 moles of MoO3. All right, so I just wanted you to see that you could turn it into moles. Now the next question is how many molecules? Well, remember that in order to get to moles, you can use mass, but you could also use molecules or particles, and that's using Avogadro's number. So we need to use Avogadro's number for this second question. I'm going to turn moles into molecules, because this goes back and forth depending on Avogadro's number. So 0.102 moles of MoO3, and how many molecules is that? Well, remember that 1 mole of anything is 6.022 times 10 to the 23rd things, 10 to the 23rd molecules. So now we cancel everything, moles and moles, and we end up with how many molecules. So let's do that math. We have 0.102, and then times 6.0, clear that out. 0.102 times 6.022 second function double E 23, enter. 6.14 times 10 to the 23rd. Now look, see this E22, oh, it's not 10 to the 22nd. E22, you have to write times 10 to the 22nd. So 6.14 times 10 to the 22nd molecules. So that is how many molecules of MoO3. And you are going to have a question that asks you how many molecules. You're going to have to use Avogadro's number. This is Na, Avogadro's number. Avogadro's number. Okay, we now percent yield. If 75.8 is the percent yield, what is the actual yield of zinc oxide? Okay, now let's look at the formula. Percent yield, and you have this formula on the test, is the actual amount, divided by the theoretical amount times 100. Okay? So we go up to the top, and what we determined was that zinc oxide, this is the theoretical amount. The theoretical amount is the amount that you calculate that could be made. This is not real life. This is theoretical right here. This is what you calculate. The theoretical amount is the calculated amount, 12.4 grams. Okay? So, remember that the theoretical amount is the calculated amount. So of this, I know the percent. I know that 75.8% is, and 12.4 grams is my theoretical amount, times 100. What I do not know is A, the actual yield. So I'm just going to solve for A in this case. Now in the past I've given you an A, and then you've calculated a theoretical and you figured out the percent yield. I'm just showing you that you can do this kind of question as well. You just got to solve for that one unknown. So we're just going to solve for A. All right? So I'm going to divide both, this is 100, so yes, I'm going to divide both sides by 100. So that goes away, and this becomes 0.758 is equal to the actual amount over 12.4. And now I'm going to multiply both sides by 12.4. And that's going to cancel. And that's going to cancel. So what's my actual amount equal to? 12.4 times 0.758. All right, 12.4 times 0.758, which is 9.40 by the time I get 3 sig figs. 9.40 grams. That's the actual amount of zinc oxide. So notice I just solved for the one unknown. If I give you the percentage, you put it here. If I don't give you the percentage, if you may be calculating percentage, you might know the actual amount from the problem, and you calculate the theoretical. Remember that the calculated value is your theoretical amount. Okay? I hope that helps you with that. Now, I do have a couple of questions with pictures. So let's look at this picture. This is the before the reaction picture. And we have hydrogen and nitrogen and ammonia. Excuse me. And this is really already circling how they're going to work, because these two separate. See that? This one and this one separates to become this one and this one. And there are 2, 4, 6 of the hydrogens, and that's 6 total. And there are 6 here. 1, 2, 3, 4, 5, 6. But when I get to the reactant side, the product side, this is the product side. And this is the reactant side. I've made all the product I can make because I used up something. What did I use up? What is the limiting reactant? Circle it on the reactant side. So notice I have these things right here. Those are the nitrogens. That's not limiting because those are extra. Those are left over. So the limiting reactant in this case is hydrogen. Hydrogen is limiting. Okay? I ran out of the hydrogens. On this side, there's no more hydrogens to react. That's the limiting reactant. So what does that make these? Those are the extras. So that's my excess reactant. I have some left over that never get used. I use all my hydrogens, but I have some unused nitrogens. Okay, let's look at the next one. And notice I told you to circle it on the reactant side. Circle that's on this side. Let's look at the next one. Before the reaction, here you have hydrogen and chlorine. And chlorine is the big green guys, and hydrogen is the little white guys. And it says, what is the excess reactant? Circle it on the reactant side. So that means the reactant I have too much of. Well, if I compare the two sides, notice that 1, 2, 3, 4, 5, 6, 7, 8. Those are my chlorines. 1, 2, 3, 4, 5, 6, 7, 8. All of them are used. So that is not that excess reactant. This is the excess reactant, hydrogens, because I have some left over on the other side. These are the extras. So this must be the excess reactant. The hydrogens. I have too much hydrogen. It does not all get used. Some of it gets used. So let's count that. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogen atoms. And over here, how many get used? 1, 2, 3, 4, 5, 6, 7, 8 of them get used. So this would have been a time when I had 12 hydrogens would have been in my given. 8 of my hydrogens would have gotten used. And so 4 would have been left over. And that's what I have here. 1, 2, 3, 4 left over that did not get used. Okay, that's the end of this video. I hope that will help you with what's coming on the test, and I will see you soon.